Okay, hello everyone. I'm going to talk about impossibility results a little bit. So the talk is going to ask the following question. Can we build VDFs from random oracles and random oracles only? And let me kill the suspense. We don't know. But I'm going to tell you what we know, like partial results basically. And this is a joint work with Caleb Smith and David Wu, all from University of Virginia. So you all know what VDF is. I'm just going to go over the notation because I want to state the result and some comments about it more formally. VDF, as we know, was introduced recently by Bono, Bose, and Fish. And the simplified form of it has just two subroutines. We need to evaluate on a input X and come up with a output Y and a proof pi in a time that is relatively long, so it's where the word delayed comes in, and we denote it by capital T just to say that this is a long time. And this Y is, even though this might be a randomized process, is uniquely determined by X, so that's why we can call it an output. It's kind of a output of a function of X. And pi might not be like that. Later on, somebody who has X and Y and the proof can verify this pretty quickly in a time that we denote by little t, and this is way smaller than the capital T. And everything could depend on a setup, but this is the simplified picture. So everything could be based on a public parameter, which depends on the security parameter. Now, the security properties, of course, we want uniqueness. Uniqueness means no polynomial time algorithm can find a different output, let's call it y prime, that does pass the verification. Can something that is acceptable, I have to make this sentence a little bit longer to state that this should be accepted, y prime. And sequentiality says that computing the correct answer would almost require you to run the honest algorithm, and t prime is the letter that we use to denote the lower bound on the adversary's running time, which is something of the order of magnitude of capital T, way bigger than little t. And to see some examples, t prime it's interesting even t over 2, but the the regime called so-called tight sequentiality, recently focused by Doetling et al., is going to be relevant to one of the results that I'm going to talk about. So you might be even interested in sequentiality that is very strong, and you want the adversary to be running in a time which is, for example, t minus like a smaller polynomial of capital T. Okay. The focus is on the assumption. What assumptions are used to build VDFs? Well, there are a lot of them by now, and this is just a snapshot out of those 76 or 70 something citations till morning. But all of them are algebraic in some form. And even if you kind of state them based on snarks or starks that are kind of primitives of their own, once you want to construct the snarks or starks, they start to become algebraic. So we are asking whether we can build VDFs from simpler assumptions, things like one-way function or hash functions. Are they going to be enough or not? And we have a model that cleanly tells us how to capture all these primitives in a seemingly information theoretic sense. That's random oracle model. Just think about a function that maps everything randomly to like k bits, k being like security parameter. The thing is that in that model you can model time and parallel time very cleanly. Time could be the number of queries. Parallel time could be the number of rounds of queries that you ask to the oracle. And then you can start to prove positive or negative results. And then the question is, can you construct VDF? Just the same definition, just substitute time and parallel time with the number of queries and the number of rounds of queries to the oracle. So this is the question. And why we care? You might say, well, VDF is so algebraic, it of course needs a trapdoor. Why do we ask it? The answer, of course, is going to be no. Well, I guess so, but I want to remind that a very close cousin of VDF is known to be implied by random oracle only. We don't need any assumption in that idealized model, and that's publicly verifiable proof of sequential work. Every word in this long phrase is a property of VDF. The only thing that VDF needs in addition is that uniqueness. So we need VDF is basically a publicly verifiable proof of sequential work where that output is unique when you ignore the proof. So you might wonder, I don't know, I still bet that it's probably impossible to construct VDF, but we still don't know. What we do prove, two results quickly. One is that if you take this uniqueness property to the extreme and you assume it to be perfectly unique, which I'm going to define in a second, then you cannot construct VDFs from random oracles only. And perfect uniqueness means that there is no other output other than the legitimate one that could be verified successfully with some proof. And I put it in contrast with the actual definition of VDF, where we are okay with computational uniqueness, where it's just hard to find one. And there are some forms of weak VDFs that are actually, this result covers. And I want to kind of just point out that if you have a permutation type VDF where the verification is just running the inversion, well, that is basically very close to something called a slot function, and you can show that that cannot be done in the random oracle model. Yes?
What's the quantification of over the random oracle in the perfect uniqueness requirement?
So perfect uniqueness, you can define it without an oracle first. But once the oracle enters the game, it should hold for every oracle. Good question. And so this is the first result. So it kind of complements results about weak PDFs of the form of permutation, but it's still, most natural, almost all natural or practical VDFs are actually computationally secure. The second result is about another types of VDFs, which are, I pointed out very quickly, tightly sequential VDFs that are recently kind of focused on by Dotling, Garrick, Moltovat, and Vasude, and one, where this is a regime where the sequentiality is just very strong and we want very, very kind of sequential functions. So I want to comment that this result is, you can extend it even to cover proofs of sequential work, which might make you wonder if this is really about VDF or it's about sequentiality. I think it's fair to interpret it as about sequentiality than being really about VDF. And the proof ideas, I'll refer you to the paper, but the first result essentially is variations of the negative result about time lock puzzles, which we had with Talmoran and Salil a while ago. We can use this as a black box to prove something, but then to prove the version that I told you, we need to kind of open up the proof and kind of modify it a little bit. The second proof, the second theorem is also similar, but it's a little bit different type. So I'll refer you to the paper. Just to conclude, the question is still open, so we have a draft online that might have a confusing title, and I talked to colleagues, they thought we have solved it. No, it is still open. But for some classes of the VDF, we know that we cannot build it from random oracle. And that was it.